Okay, let's discuss the principle of moments, which is related to torque, and we have already studied what is torque, so it won't be a problem for you to understand the principle of moments now. So the principle of moments states that if a body needs to be in a balanced state, the sum of okay, let me write it down. For a body to be balanced, for a for for a body to be balanced, for a body to be balanced, the sum of clockwise clockwise moments should be equal to the sum of the counterclockwise moment, right? So you need to see that this is a pretty simple principle which states that for a body needs to be balanced. So the first thing that we are going to see is that or observe is that it is to be stated for a body that needs to be in a balanced state, right? So we will see what balancing of a body means. The sum of clockwise moments should be equal to the sum of counterclockwise moments, right? So clockwise moments should be equal to the counterclockwise moments, right? So we can actually elaborate that by actually looking at an example of the seesaw, which is a perfect way to understand the concept of principle of moments. So this is a seesaw which has the potential to rotate both ways. It can rotate this way, which would be counterclockwise, or it can rotate this way, which would be clockwise, right? So although both of these arrows are pointing downwards, but we are not actually talking about the directions in rotational motion as upwards and downwards. In fact, we actually talk about the directions in the terms of clockwise and counterclockwise. All right. So whenever we're talking about rotational motion, you need to keep the directions that way, right? So this is the clockwise and this is the counterclockwise. And you can remember that or you can memorize that because you can always see the needles of the clock to be going this way, so that is clockwise, and this is counterclockwise because the needles of the clock don't actually go this way, right? So this is opposite to that. That's why we call it counterclockwise. So if the seesaw is rotating this way, it is called clockwise. If the seesaw is rotating this way, this is called counterclockwise, right? So you can put some objects on the seesaw and then see the turning effect that or the torque that is being produced by each of those boxes. For example, you can put a box of some weight here and which will be making or which will actually affect or cause the seesaw to rotate clockwise, or you can just put another box here which would also cause the seesaw to rotate clockwise, and you can just put a giant box here which would actually cause the seesaw to rotate counterclockwise. So all of these boxes are going to add some amount of torque into that seesaw, and they will try to create some turning effect depending upon their weight and the distance from the pivot. But if the seesaw needs to be in a balanced state, that means perfectly horizontal, right? Then the principle states that the overall sum of clockwise moments should be equal to the sum of clockwise moments. Like the torque that is being produced by this giant box here, which is the product of the force or the weight of this box from and the perpendicular distance, the product of force and the perpendicular distance would actually give you the torque that the overall counterclockwise torque should be equal to the sum of the clockwise torque. So the weight of this and the product of the distance that it has from the pivot and the weight of this box times the product of the product times the distance of the box from this point to the pivot, right? So the sum of these two torques, right? So this is a torque and this is a torque. The sum of these two torques should that are actually adding to the clockwise moment or clockwise, direction should be equal to the moments that are actually wanting the seesaw to rotate counterclockwise. So if the total clockwise moments and the counterclockwise moments are balanced or they're equal, then the seesaw will be in a balanced state. So this is, how you can easily understand the principal moments. So we can actually talk about an example how we can actually use the principal moments in order to calculate various weights or various distances or various torques in the next video.